Wait for a few minutes more so that the things get right. Made on the WhatsApp, and I was seeing that some of the section has too many students and some are too less. You all have joined your own required section or according to work, and we tried to discuss about the work, the measurement of work, okay, how the work can be measured, and then we studied about a mathematical expression for finding out the work. That was Fs. W is equal to F into S. We also found out that if on application of force, if the body is getting displaced by an angle theta, in that case, how we are going to find out the work done, which comes out to be Fs cos theta. So to find out this Fs cos theta, we have two ways. One is to resolve force in the direction of displacement. The other is your to resolve displacement in the direction of force. So overall, we find that the work which is done, that is going to be depending upon three main factors. That is your force, magnitude of force, displacement, and the angle between the force and the displacement. We also started with the special cases. Okay, special cases are when the on application of force we are able to find that it gets displaced by a certain standard angle. The two angles which we have studied, that is the two cases which we studied last time. That was when the angle is theta, when angle is 0 degree, and when the angle is 90 degree. In case of 0 degree, we find that the work is basically positive because cos 0 becomes 1, and as a result, W is equal to Fs cos theta will give you W is equal to Fs. And there were two examples which we discussed, that is freely falling body and a pulley who is trying to lift the load. So in that case, we find that the work done is positive. There were other examples also. Then we have studied about the second case where the angle between the force applied and displacement happens to be your 90 degree. That is, the displacement is perpendicular to the force applied, and in that case, no work has been done. So, if the pulley is walking, so during the walking, the load is perpendicular to the displacement along the horizontal ground, and therefore we find that the work done will be 0 in that case. Similarly, the work done by the body due to the centrifugal force, that is also 0. So today we start with the third case, that is when theta equal to 180 degree. So I hope you are able to see this. Now, when we consider that the theta is equal to 180 degree, what does it mean? It simply means that, so here we have the theta equal to 180 degree, and it simply means that the displacement is opposite to the force. So here we find that the displacement is opposite to the force applied, which means that if you are generally applying the force either to stop a moving object or you are trying to have a motion in the opposite direction or apply the force in the opposite direction. Okay. Cos theta equal to 180 degree, we'll find that the value of cos theta is -1, and when you put it into the formula, W is equal to F into S cos theta, therefore you will find that Fs becomes negative, and therefore the work done is negative. Keep in mind, here it's the direction or the deflection, direction of the force, either it is opposite or the direction of the displacement is in opposite, and that is why this negative sign basically represents your either force or your displacement. But then on the whole, you can say that if the work done comes out to be minus Fs, it means that the work is done against the force. Now, the examples for such type of condition or for this condition, this is the work done by the friction, force of friction, that is your negative. Now, in this case, if you observe, if the body is getting displaced from one point over here to the other point over here, okay, so the force of friction which will be towards the lower end, if you observe, so this will be in the opposite direction, okay. As a result, we will find that here the friction is in the opposite direction. As a result, you will observe that the work done by the friction, keep in mind, we are finding out the work done by the friction, and that will be your negative. The other case is the force of gravity. If the body is thrown up, so if you have a body of mass m and it has been thrown up, the force of gravity will be acting downward. This will be the force of gravity which is going to act downward. The direction of the deflection is in upward direction, and as a result, we will find that this will be equal to Fs cos 180 degree, which is equal to minus mgh. Now, in the first case, when the force was in the direction, say for freely falling body, that was positive. There also the work done was by the gravity, and here also the work done is by the gravity. But we are trying to find out in the two different scenarios. Okay, one was here when the body was freely falling, and the other is when the body is undergoing the upward motion, and therefore you will find that in this case the work done is going to be minus mgh, okay, where mg will represent the force of gravity, which is the weight, and s will represent the height to which it has been thrown up. Okay, now you might be seeing the arrow has been marked down. The arrow has been marked down only to indicate this as a force of gravity. We are trying to find out the direction, the work done by the force of gravity. Say, for example, if you try to find out the work done by the ball, okay, then that will be your positive, because the ball, the force is applied in upward direction, the ball is moving in the upward direction, so the work done by the ball will be your positive. If you remember the second example in case of your lifting the load by the pulley. So this is how you have to be very careful what has been asked and what you are going to calculate. I hope your attention is in the explanation part. So some of you are using the screen also. So we come to the next portion. So yesterday we studied about W equal to 0. That is when displacement is uh, perpendicular, we find that the work done is equal to 0. So this also gives us the condition to determine the work done by the force to be 0. Keep in mind, we are determining the condition for the work done by the force equal to 0. Now, we are trying to find out the work done by the force. Okay? So force has got the magnitude. Now, if the force has got the magnitude, then what are the conditions under which the work done can be 0? So there are two conditions. One is S is equal to 0. That is, the displacement is 0. There is no displacement. And we have already studied that if there is no displacement, then the work done is said to be 0. Okay. Similarly, the other case when the work done can be 0 is when theta is equal to 90 degree. That means the displacement is normal or perpendicular to the direction of deflection. So now if the direction is perpendicular, then also we find that the cos 90 is equal to 0 degree, and in that case also. So there are two cases in which when you apply the force and the work becomes 0, that is either there is no displacement. So for example, if you apply the force on a wall, you are applying a force but the displacement is 0, or when the angle between the force applied and the displacement is 90 degree. Okay, so for example, the work done by the coolie carrying the load on his head. So that means whenever it has been asked to specify the condition or to give the condition when the work done is 0 by a force, please do not write down force equal to 0. So here, if you see, force cannot be 0. Okay. So this was about the work done. The special cases. So we have studied about the 3 different cases for the work done. Now how to calculate work with respect to, or how can we represent work graphically? So whenever we have to represent work, we represent work by force displacement graph, where the force is represented along y-axis and displacement is taken along x-axis. Okay. So if you see, so how this force displacement graph is going to provide us with the work done. Now force displacement graph will be providing us, or we will be able to use this force displacement graph to find out the work done only if we are able to find out the area enclosed within the graph. Okay. So if we are able to find out the area enclosed, then now why we say that we have to find out the area enclosed? What will happen if we try to find out the slope? Okay, generally you know that. So we are taking here 2 different cases. In the first case, a variable force has been applied, which causes the displacement. And the second case, the force is constant. Now, in the first case, when you see, the force is going to be applied the force is going to be applied, and the graph you get it is what is being shown in the first diagram. Okay, so here if you try to find out the area, let us try to find out the area of this graph. So the area enclosed within the graph, that is enclosed within the triangle, that will be in the shape of triangle OA and S. Okay, so this is a triangle, and we all know that the area of the triangle is given as half base into height. So here your height becomes AS and base becomes your OS. Now AS will represent OF, that is your F, whereas OS will represent the displacement, that is S. So if you try to see this portion, then we will be able to make out that force into displacement is given as force into displacement. Force into displacement is work. Therefore, the area enclosed within this graph is going to give us the work done. Similarly, if you go to the next one, we have the graph of a uniform force or a constant force, and therefore the graph is going to be parallel to the x-axis, that is your displacement. Now suppose if we try to find out the work done by finding out the area, now why we need to find out the area in this case also. So let's see. So here if we have to find out the work done, then we will be finding out the area enclosed by the triangle, by the rectangle OABS. So this is the rectangle whose area we will be finding out. This is the rectangle whose area we will be finding out, and to find it can be OA into OS or OC. Okay, so OA will be representing the force F, OC will be representing the displacement S. So we again get it as the product of force and displacement. Again, product of force and displacement gives us the work, and therefore whenever we have the force displacement graph, the area enclosed within the graph will give us the work done. And that is why if you have to find out the work done in case of the force displacement graph, then we will be finding out the area. That is vice versa. So I hope up till here it is clear to all of you. All those who are annotating or doing the scribbling, their names are coming to me. So kindly, in the next class, you might not be allowed to enter. So please don't do the annotation. So now we move to the next portion, that is your work done by the gravity. We have already done this work done by the gravity. Now in this case, just sum up what we have already done. We know that if a body is freely falling, there are two cases when the work is done by the gravity. One is either the body is falling down freely under the influence of gravity, or a body is being thrown up. Okay. Now, if the body, now keep in mind here we are trying to find out the work done by the gravity, and as a result, we find that the body is freely falling, W is equal to mgh, which will be positive. If the body is going upward, will be equal to mgh. Minus mgh, that is your negative. So keep in mind, in case of a body which has been falling down from a height, or it has been thrown to a height, the work done, the magnitude of the work done will be same. The only difference is that in one case, it is the displacement is in the direction of the force applied, that is your uh, in the direction that is falling down, the force of gravity is also coming towards the lower side or downside, and the displacement is also down, so it is positive. Whereas in the other case, when your body is thrown up, so the negative sign indicates that the displacement is opposite to the direction of force of gravity. Another important part which should be noted down, sometimes we reach to a height, say a ball has been thrown up or it has been dropped, but if you have to go to a certain height, you either use a staircase, or you can use an inclined plane, or you can use a elevator. Now, staircase, if you observe, is just like an inclined plane. Now, we are basically required to find out the initial and final position is from ground at what height you are. And therefore, the means through which you are going, that is immaterial to calculate the work done. Which means that whether you are going by the staircase, whether you are going by the inclined plane, or by the elevator, or you are coming vice versa, then the work done is going to be, the height is going to be considered as h. Okay, whatever means you are going, so that is not going to be considered for calculation point of view. So I hope up till here it is clear to all of you. If you have any problem, you can raise your hand, you can put some chat. Please, all those who are using their screen, or when I am explaining and you are also scribbling, please don't do it. You are disturbing others also. So, sorry, you asked that work done by the action of moment force is 0 when the cos theta is 90 degree. See, when we are talking about the work done, okay, torque is a different thing. That is why we have said that torque is a different physical quantity, and work done is different physical quantity at all. Okay, just like two of you boys are sitting in the same class, but still they have their different individuality and different property. Okay, they may be taught by the same teacher. That means here the concept is different, and therefore you cannot use the same thing. Is there also which half the work done calculated by finding out the area? 1/2 is basically been used because the shape which is there, that is of triangle, and we all know that for the standard or for a basic formal, for the particular shape like equilateral triangle or scalene triangle, we generally use half base into height. Okay, so we are using over here as half. So half is not the standard part of the formula, it's just the standard part of your mathematical formula. Again, Divyanshi, your question is that at 90 degree work done is 0 as the luggage has displacement with the force of gravity. Yes, the weight of the luggage is going to be acting downward, which is your force of gravity. So here the force applied will be your force of gravity. But the force applied by, or rather the displacement which this luggage is going to take place, that is as the pulley is moving along the horizontal plane. And therefore, what we find is that the displacement becomes 90 degree, and hence the work done becomes zero. So I hope it's clear to all of you now. So I'm moving to the next portion. Today many are not there also. Why so less attendance? Keep in mind it will not be repeated again, because we don't know when the school is going to be open. So please attend the class. So now we move to the next portion. So we move to the next portion, that is what type of quantity is work. Now we all know that work is a scalar quantity. Now quite often there was a argument, or there was a discussion between torque and work. First of all, the torque and work are two different quantity at all. Okay, so they have different use, or you can say they are different physical quantity. So their behavior is different entirely. Now, so here if you see, I've also written why it is. So whenever we are required, now scalar quantity, you all are aware that scalar quantities are those quantities which only magnitude is required, which gives us the complete information. So whenever you are telling about work done, you just mention the unit, mention the magnitude, say so much joules of work done, 100 joules of work done, 50 joules of work done. Okay, even when we are saying positive or negative, we are not specifying the work done. Positive, negative is basically specifying the direction in which the work is being done. Okay, or rather, not of work, direction in which the force or the displacement is taking place, not for the work done. Therefore, work is a scalar quantity. When we come to the unit of work, we all know that the unit of work in SI system, it is joule, and it is CGS system, it is arc. Keep in mind the method of writing down the unit. There are specific guidelines you have studied in class 9. Okay. So follow those guidelines, and accordingly I have also written in the same. So if you are writing down the complete name, it will be in small letters. If you are writing down the abbreviations for name of the scientist, capital, and other, it will be a small letters. Now let us try to define when we can say that the work is 1 joule. Now 1 joule is basically equivalent to 1 Newton into 1 meter. Force, Newton, displacement, meter. Now, what does this mean, 1 Newton into 1 meter? It simply means that if you apply a force of 1 Newton and it causes the displacement of the body in the direction of the body by 1 meter in the direction of the force applied, then the work done is said to be 1 joule. So here the definition which has been given, that is 1 joule of work is said to be done when a force of 1 Newton displaces a body through a distance of 1 meter in the direction of the force applied. The references are from your Selena book only, Concise Physics. I'm not taking the references, so standard references we will be referring to the Selena. So definitions and other things, and most of the portions you will find it is from the Selena itself, in order to avoid any type of confusion. So 1 joule, I hope it is clear. So 1 joule is basically, if you apply a force of 1 Newton and it causes the displacement of 1 meter in the same direction in which you are applying the force, then this is said to be of 1 joule. And similarly, CGS system is arc. The unit of work in CGS system is arc, ERG, and all should be written in small. Keep in mind, we don't write down ergs. Okay, S should not be written because the units do not have the plurals. Now, one erg will be, since it is the CGS unit, so the unit of force will be in CGS system, that is dyne, and unit of displacement will be in CGS system 1 centimeter, and therefore it comes out to be 1 dyne into 1 centimeter. Simply means that if you apply a force of 1 dyne, which causes the displacement of 1 centimeter split by 1 centimeter in the direction of application of force, then the work done is said to be of 1 erg. So if we have CGS system and SI system, then we should have a conversion factor also. Now the conversion factor says that is 1 joule. What is the relation between joule and erg? 1 joule is equal to 1 Newton into 1 meter. 1 Newton, we all know that it is 10 to the power 5 dynes, and 1 meter is equal to 10 to the power 2 centimeter. And finally, it comes out to be 10 to the power 7 dyne centimeter, which is equal to erg. So we can say that 1 joule is equivalent to 10 to the power 7 erg. Now, you should know, you should go through it. This type of calculation quite often come in the section 1 of your examinations. You should be familiar with this. This is a simple one. So this was about the relationship between joule and erg. So this was all about work. Okay. So I hope up till here it is clear to all of you. If you have any question, you can ask in the chat. Don't get confused with the right angle which I have drawn. That is a case when the force is variably increasing. Sorry, velocity is force is increasing and it makes an angle of 90 degree. It's not always that you will be getting a triangular formula. Okay, so therefore this will not be 90 degree. So 90 degree is that the displacement of the object. Okay, if you apply a force and the force moves to 90 degree, so that will form a 90 degree triangle. Okay, that will form cos 90 equal to 0, and hence the work will be 0. I hope my is clear. What is FPS? FPS, you can find out the unit. This can be put as an work you can do. Your FPS system is your foot, pound, and second system. Okay. Now force you will you will be finding out in terms of foot and pound. So force will be your pound per feet per second square, and your time will be your displacement will be your S, that is your feet, and therefore I'll just tell you cube per second. So you don't have any specific unit, you can find out. Relation between joule and erg I have already told you, that is 1 joule is equal to 10 to the power 7 ergs. I hope Ankur it is clear. The basic difference between unit of force and work is that it is unit of force is a vector quantity, unit of work is a scalar quantity. So we use joule for work and Newton meter for force. explain you that later. We'll have to see what it is given and what it is trying to find out. Okay. Actually, you will find that in that case, we'll come to the numerical part a bit later. It tells the direction of the force or displacement, not of the work. So Divyanshi, it is basically a scalar quantity. Work as a whole is a scalar quantity. What we mean by saying positive or negative is only for force or the displacement. Either the force is opposite to the direction of displacement or displacement is opposite to the direction of force. And that is why it comes out as negative. Okay, so work is never negative. Okay, work, we say that work done is negative, it simply means that the force applied is either opposite or displacement is opposite. So I hope that is clear. Divyanshi? Now, here, Pratham, you have asked that coolie is standing with the luggage on his head. Okay. Now, when the coolie is standing with the luggage on the head, the work done by the luggage, that will be your positive, because that weight of the luggage, that is force of gravity, will be acting down. Sorry, that will be zero. Displacement of the luggage is going to be zero, and therefore that will be, work done will be zero. See the example number, the case 2, example 2. In case of that, you will find that the centripetal force basically that is 90 degree to the displacement, and therefore this is 0 degree. And same thing is happening with the satellites. So I hope, Aditya, it is clear. Again, I am telling you, please do not confuse with the negative and positive work. Negative and positive signs are only telling you the direction of the force applied and the or the displacement, which means that it is opposite, and that is why it comes out as negative work. Okay, so negative sign basically does not gives you the work as negative. It indicates that the direction of force and this displacement is negative. We are determining the direction of the force and the displacement, because both of them are your vector quantity. Work, we are not determining that. Okay, you might be confused that the angle has been given. Angle is when we are trying to resolve the direction, means if the direction is not in particular along the direction of the force applied, then we are trying to resolve and we are getting it as cos theta. Okay, so keep in mind the work is always a scalar quantity. Whichever direction you do, the work you require to only specify the magnitude. Okay, so quickly we will go to the last two parts, that is all right. So now we come to the next portion, that is power. Power is another factor which is related to the work. And to define power, we define it as the capacity to do, the rate of doing work is called as power. Means how much work you can do with respect to time. Rate whenever we are using with respect to time. And mathematically we can express power as W by T, and work spent by the source is measured as the amount of work done by the source in 1 second. That is how we can define power as P is equal to W if T is equal to 1, which means that the power is equal to work done in 1 second. So which also indicates that the power is going to be affected by two factors. One is the amount of work done and the time. And if you see, for example, if you are doing the work in the same time interval, two work you are doing in the same time interval. In one case, you are doing more work, in the other case you are doing less work. So the power which you will be using will be more in case of more work and less in the case of less work. And as a result, the power becomes directly proportional to work. On the other hand, if the work is same, but it has been done in two different time intervals, one is taking more time and one other is taking less time. So the one which is taking more time, there the power will be less because you are using lesser power, therefore more time it is taking. And where it is taking less time, your power consumption will be more. Okay, so if you see, for example, engine, if you see the power of the engine, the whose power is more, okay, that takes less time to do the work, whereas the engine whose power is less, that will take more time. Say for example, submersible, if you are using same amount of, okay, so you have different power rating of the submersibles, okay, some may be of half horsepower, some may be of 1 horsepower, some may be of 2, some may be 5. Say for example, if you require a huge tank to be filled, you require larger amount of water and time should be less. So the power there you will be finding it will be more. Okay, so it will be taking lesser time to take out more water. A half horsepower motor will be taking doing less work in the same time interval, which means the amount of water which will be drawn out will be less. Okay, so this is how it is inversely proportional. Power can also be said to be related to the force and the average velocity. So if we consider a body which has got a mass m and a constant force is being applied, which causes the displacement of the body by s in the same direction of the force in time t. So work done will be equal to F into S, power will be your W into T. So we are applying a constant force F, displacement taking place is S in the time T. So now if we try to rearrange this power, so power is equal to W by T, W can be replaced by F into S, or we can have F into S by T. Now S by T gives us an average speed or simply speed, and therefore we can replace that by V, and hence P is equal to F into V. So this also, so if you know the velocity of a body and the force applied, you can still find out the power, or any of the two is known, the third can be calculated. Then we have the nature of power. Power is a scalar quantity. Again, to specify power, we do not have to specify the direction. And the unit of the power is joule per second. And this is also called as watt. So this is called as your watt. This is the SI unit. In CGS unit, it is erg per second, written as ERG per second. Try to write down as a negative power, you have the unit in the denominator. Now what is 1 watt of the power? 1 watt is equal to 1 joule upon 1 second, which means that if 1 joule of work is done in 1 second, then the power spent by the body will be your 1 watt. Okay, so if you do 1 joule of work in 1 second, the power spent will be your 1 watt. And similarly, the relationship between SI and CGS unit, 1 watt will be equal to 10 to the power 7 ergs a second. Another unit of power is horsepower, which I was using just now. This is basically been used for the machines and in mechanical engineering devices. Okay, 1 HP is equal to 746 watt, and it is equivalent to 0.746 kilowatt. So this was about power. So we'll go through the chapter and go through each and every portion. I'll be putting this or sending this. If you want today, I can send it today, or otherwise maybe 1 or 2 days after. Will be on Monday. But before this, you should all complete your previous work. Don't keep them pending. Then we have energy. Energy is again related to work. If you are highly energetic, you will do more work. If you are lost your energy, you will do less work. Early in the morning, you are energetic. Okay, but by the end of the day, you got tired. For example, you are early. In this beginning of this class, I was energetic. Now I am getting tired. Okay, so it is defined as the capacity to do work. By nature, it is also a scalar quantity. The unit of energy is same as that of work. So, as much work you do, that much energy you are spending. Okay, so therefore, energy is basically function of work, and vice versa, you can say. So the unit also becomes the same as that of your work. SI unit is joule, CGS unit is erg. And there are some other standard units of energy. For example, watt hour you use. This is basically for the electrical energy, and that is equivalent to 1 watt into 1 hour, and that is 3600 joules. Then we have kilowatt hour. Then we have kilowatt hour. This is again another unit in which the electrical energy is consumed is calculated, especially at your home. The electricity bill comes in this unit only. This is 1 kilowatt into 1 hour, and 1 kilowatt equal to 1000 watts, which is equal to 1000 joules per second into 3600, that is 3.6 into 10 power 6 joules. Another exclusive unit of energy is calorie. Generally, to measure the heat of a body, we are using calories, and 1 calorie is the amount of heat energy. I hope all of you know the definition. It's the amount of energy required to raise the temperature of unit mass of 1 gram of water from 14.5 to 15.5 degrees centigrade. So if we calculate it in joules, it will be equal to 4.18 joules, or for simplification we say it as 4.2 joules. So 1 calorie is equal to 4.2 joules. The next is your electron volt. Now, electron volt is basically being used, as the name suggests, electron. So this is equivalent to the charge on 1 electron into 1 volt. This is basically being used to measure the energy of very small thing, or very small quantity of energy, such as subatomic particles. Okay, if you have to find out the energy or work done for subatomic particles, we are using this electron volt. So this is equivalent to charge on 1 electron into 1 volt. Now charge on 1 electron is 1.6 into 10 power minus 19 coulomb. Coulomb is the unit of charge into 1 volt. That comes out to be 1.6 into 10 to the power minus 19 joules. The definitions have been given over there, so you can go through the definitions. Please learn this. Quite often it has been asked in your boards. Okay, it will be coming in 1 or 2 portion, and as a result, please go through thoroughly. These are very important chapters, and now I'll be sending it. If you want it today, I'll send you today. If you want it some other time, I'll send you by Monday then. I hope I am not going to send it today. For today onward, you will do the previous work. I don't want to burden you with this. Okay, so I'll send you. If you have done it, well and good, go through the questions, and please do the numericals. This portion, A portion is over. Go through the question answers, go through the numericals, and then I will post it on Monday. And we might be having a class on Monday. Let's see what the timetable comes. Tomorrow also we have, but I don't know whether I will be there or not. Okay, so please go through. If you have a problem, I am still open. I have kept the group open. Okay, post your problems, and you will get the solution to that. I hope so. So now I'm ending this. So I hope everybody is doing with 12. Please take your studies seriously, and especially the boys. I don't find them asking the question. Very few of them are asking. And please, if your number is not showing your name, please, I would like to have your names also. And please tell the section, because some of the sections are having 74, 84 participants with groups, which means that they are students from the other section also. And please, all of you, please, if anybody is still left out to be added to the group, please ask him to send the detail to me. I'll add him up. So have a nice night. Okay. So good night.